This is the another problem about the semicircle centroidal axis with you have to finding. Okay. With so here with respect on x-axis you have to determine. In this, the centroid will always lies on this x-axis. Okay. But where it lies, okay, at what distance you have to find lies, that you need to determine. Okay. See here, in the here, this is the small elemental area, elemental area, dA, that is called as dA. Okay. So in this small elemental area, you need to determine the area. Okay, how to determine the area means it is utterly looks like a rectangle. In this rectangle, the area of the rectangle is length into breadth. Breadth is dr, length is r d theta. You just remember this. Okay, so in the previous derivation I told what is the, this is an arc length. Okay, how the arc length which is came, so that in the derivation of the circle, centered of the circle, I explained. Please go through that videos. In this, the arc length is r d theta. So the distance from the origin to the small elemental area is r. So the distance, the height, consider this, whatever the dot I am showing here, that dot is the center of this elemental area, center of this smaller elemental area. Okay, so in this, the height, the center of the smaller elemental area to x-axis, the distance is y is equal to r sin theta. So that's what the distance. Okay, so if you want to find out x distance also, means you can draw one the distance, draw a straight line from here to here. Okay, from here to here it is r cos theta, here it is r sin theta, here it will be r cos theta. X is equal to r cos theta, but we don't need to that. We have restricted only to y is equal to r sin theta only. Okay, so that's about the y distance. So the arc length is r d theta, distance from here to here it is r d theta. So finally the area of the dA is what? One is length is, that is r d theta into dr. So I will write it as dA is equal to r d theta into dr. So that's what it is being written here, dA is equal to r d theta into dr. Okay, so remove the bracket, you can write it d as r dr into d theta. Okay. Next, the this y distance. Okay, whatever I'm showing here, y distance, this is the y axis. Okay, in the y axis, the vertical distance is y is equal to r sin theta. Okay. So I've written that one as y distance, y is equal to r sin theta. Okay, now I need to determine the moment of inertia. Moment of inertia is what? The smallest elemental area into vertical distance, square of the vertical distance. Okay, this is what the formula, correct? So this is what the formula you need about the moment of inertia. If you take a smaller area, okay, this is for a bigger area. Okay, I is for a bigger area. For smaller elemental area, what should I take it? So I will write it as di. Di is equal to, what is this? Y square is the distance. It is the distance. I will write it as y square as it is. I will not change. Okay, distance will remain same. But area is a bigger. Before it's a bigger section, it is the area is A. But smaller elemental area, the area will be, what is that area? That is dA. So we call it as, for a smaller elemental area, I will call it as dA. So anything, if the length we want to express in the smaller, means we will write it as dl. If the depth it is a smaller area, means we will depth we call it as h, means what we will write it as dh. Okay, so like this we will write it for a smaller things and all, we'll write it in the dl and dh, like that. So like that same way the area also it will be written as dA. Okay, now what I will do is di is equal to y square into dA. So in the place of y, I can write it as r sin theta. So I will write it as r sin theta. Okay, in the place of y. Okay, so now that whatever the di is equal to y square dA is there, so I will write it that equation. Okay, I know that y is equal to r sin theta. In the place of y, I will just substitute it. Okay, I will just substitute it. Then I will get it as r sin theta whole square into, so dA. So in the place of dA, I will write it as this equation. Okay, that is r dr into d theta. Now r into r, if you remove the bracket, r into r square, so this will become, if you remove the bracket, r will become r square and sin theta will become sin square theta. Okay, so this is r square and into r it will become r cube. Okay, this is sin square theta, you write it as it is. Dr into d theta, you write it as it is. Now integrate on both the sides. Okay, so if you integrate di by ab, AB is what I have written means this is the reference axis, so that's why you are doing the with respect to AB, so that's why I am writing as di AB. Okay, then it is r cube sin square theta dr into d theta. Okay, so that's about next you do the double integration. So first I will do with respect to d theta, then I will go with respect to radius. Okay, so radius varies from 0 to r and 0 to pi, because it is a semicircle. See here, it is a semicircle, so angle varies from 0 to 180 degree. So if you take a line, so angle varies from 0 degree to 180 degree. Okay, so that's why limit is 0 to pi. Sin square theta, so using the cos 2 theta formula, sin square is equal to 1 minus cos 2 theta divided by 2. Okay, direct formula, you know the trigonometric function, so by using that, so I'm using the direct formula. Okay, so previously I have done on this, so if you want once again means I will write it. See here, cos 2 theta is equal to 1 minus 2 sin square theta. I need it sin square. Okay, so what I will do is this I will send it here, so this I will send to here. Okay, so finally this will become 2 sin square theta is equal to 1 minus cos 2 theta. Okay, so 2, whatever 2 is there, I will send to denominator. Okay, so finally sin square theta is equal to 1 minus cos 2 theta divided by 2. Okay, sin square theta is equal to 1 minus cos 2 theta divided by 2 is the formula. So I'm using the same thing here. 1 minus cos sin square theta is equal to 1 minus cos 2 theta divided by 2. Okay, so if I integrate, what I will get it is first the 2, whatever 2 is there, I will remove outside, so it will become 1 by 2. Now, so what you will get it is the integration from 1 minus cos 2 theta, you are integrating with respect to d theta. Okay, so if you integrate 1, you will get theta, cos 2 theta, if you integrate, you will get sin 2 theta. Whatever inside it is there, inside you have to differentiate 2 theta with respect to theta, d theta, if you differentiate you will get 2, so that you have to keep it in denominator. Now your limiting value is 0 to pi. Okay, now in the place of theta you have to put the pi value. Okay, theta I have put it as upper limit as theta and again lower limit as 0. Okay, so first one finished. Next, this part, sine of any pi, sine of, consider one is r pi, another is even pi, so both it will be 0. Okay, next is sine to 0, I will put the lower limit value, that is sine 0 divided by 2, so this will become 0 and again this will become 0. Okay, so finally you leave it. Pi minus 0 is, you will get answer, total answer is pi. Okay, total answer is pi. So that's why the whole term will be reduces from this limit 0 to pi. Okay, the whole term whatever it is there, it will be reduces to pi. So that's why here this whole term whatever it is there, that is reduces to pi. Okay, next r cube and dr whatever it is there, so I kept it as it is. Okay, now r cube if you integrate, so it will become r to power of 4 divided by 4, but again multiply by 2, you will get 8. So pi r square by 8 is the moment of moment of inertia of the semicircle. Okay, so that is what the answer. Okay, next according to moment of inertia formula, this you got the centroid formula of the circle. Okay, semicircle. Next you have to find out the moment of inertia. Okay, moment of inertia for a distance of 4r by 3 pi from a AB you have to determine. So IAB is equal to IG plus AD square. This is the general formula. Okay, got it. So this is what you have to do it. Later use this formula. Later what you do is you send IG, you keep it as it is. We need IG, so you send AD square to this side. So IG is equal to IA AB minus AD square, you will get it. Okay, so area is equal to pi r square. This is general formula. Area is equal to pi r square divided by 2. So centroid of the semicircle in the previous chapter, in the centroid we have determined for a semicircle it is 4r by 3 pi. Okay, so put the a value and d value here. So finally this I value we have determined pi r to power of 4, that is moment of inertia for a semicircle is pi r to power of 4 divided by 8. Okay, so a value and d value substituted. So after this you make simplify this, then finally you get this, the r here r to power of 4, here r to power of 4, it will be common, so remove outside. Okay, so after removing that you will get r to power of 4 pi by 8 minus 8 divided by 9 pi. Okay, if you simplify this you will get 0.11 r to power of 4, that is Ig value. So you know Ig value and ADA, you know both. Okay, so this is what the final derivation of semicircle for the moment of inertia. So that's completely the moment of inertia of the center. Till here you do it and leave it. If possible you try to get it, or you can leave it till here only. Okay, till here you do it and leave it. Okay, otherwise you till maximum you do it till here. Okay, you can simplify this also. Finally you write it here Ig value and IAB value, and finally you